So, hello everyone again. This is lecture 4 part 2 of communication systems. In the last part we were studying about the mathematical formulation related to calculation or superposition when a carrier wave gets mixed up with a message signal. Let us move on with the discussion again, and then after I think next part a communication system will be completed. Let us move on with our discussion. I am Sameer Lavankar. Let us move on. So, right now we are on lesson number 8. Everything beyond or apart from lesson number 8 is completed clearly. Let us move on with amplitude modulation only. So, in the last lecture we were conducting let C of t is equal to AC sin omega ct and m of t is equal to am sin omega mt. So, modulated signal Cm can be written as in this form. Now, in the last lecture finally using this trigonometric relation we were at this point that we found out the modulated signal equation as Cmt is equal to AC sin omega ct plus mu AC by 2 cos of omega c minus omega m into t, which is also known as lower side frequency. Let me denote it as lower side frequency minus mu AC by 2 into cos of omega c plus omega m by into t, which is also known as not the t part. Let me not very much clearly, not the t part, only this omega part, because t is so varied. This is upper side frequency, that is USF. So, this point is also clear now that omega c minus omega m and omega c plus omega m are respectively called the lower side and upper side frequencies. Next point, let us move on to today's discussion now from this point here. So, the modulated signal now consists of the carrier wave of frequency omega c plus 2 sinusoidal waves. So, now what does this line say? That the modulated signal, this is let me change the sign for more clarity, let me change the color for more clarity. So, now consists of the carrier wave of frequency omega c. So, there is a carrier wave of frequency omega c. Why it is known as frequency omega c? Because a subscript of c is used here. So, it consists of a carrier wave of frequency omega c plus 2 sinusoidal waves. Sinusoidal as in either it is a form of sine or cos. So, it is known as a sinusoidal wave. Which are these two? This is the first sinusoidal wave here talking about this, and this is the second sinusoidal wave, each with a frequency slightly different from the main frequency. So, as it is something omega c plus minus omega m. So, there is a variation in frequency, hence it is slightly different from the frequency of omega c, which is the line written here, and hence these are known as sidebands. So, these both are known as sidebands, that is 1 and 2. So, 1 and 2 are known as sidebands. Let me change the color again. So, this was the concept being talked in this last second point. Moving on to the last point here. So, the frequency spectrum of the amplitude modulated signal is also shown in the figure. So, what is the frequency spectrum? So, frequency spectrum is just a graph between omega, that is frequencies, with the amplitude. So, for omega c we already know the angular frequency corresponding to omega c has an amplitude of AC, and here for a amplitude of omega AC by 2 we have omega AC by 2, and here also omega AC by omega AC by 2 has a what we can say the angular frequency of either omega c minus omega m and omega c plus omega m. So, this is only the concept term, this is nothing but a new thing or a physical term for frequency spectrum. So, this is known as the frequency spectrum. So, moving on to the next point now. So, as long as the broadcast frequencies, that is carrier waves, so carrier waves are also known as broadcast frequencies, are sufficiently spaced out so that the side bands do not overlap. So, these are the side bands, these are nothing but side bands. Why are they side bands? Because they are in sides, as clear by the name only. So that the side bands do not overlap. So, it is clear that they are not overlapping anywhere. Different stations can operate without interfering with each other. So, this line only says that as long as frequency, that is carrier wave frequency, does not get overlapped with any of the side bands either from another portion. Let us say there are two frequencies being talked about, both will have a side band. If both will have a side band and these two side bands does not get overlapped, that is let us say one is here, one is here, there is no overlapping between them, hence there is no interference. If there is no interference, then the information can be bypassed very clearly from point A to point B. This is only the concept being talked about in this portion, because it can be said as a, let us say there is a complete stone which is from let us say 0 to 5, and if I put a stone from 2 to 2.5 to let us say 7.5, then there will be a portion where these two will overlap. This overlapping will not be available if we need to put both the stones at the same place. or in the same line. So, this is only a concept we talked about. So, if there is no overlapping, then the communication is very peculiar, it is very easy and it can be directly done from point A to point B. So, this was the point being talked about in this last point. Now, let us move on to a very simple problem in your NCERT book only to just understand the concept of modulation index and the sidebands. So, modulation index is nothing but we already learnt about this, I think 2 slides back. It was nothing but the ratio between AM and AC. So, please look over to the problem now. So, a message signal of frequency 10 kilohertz and peak voltage 10 volts is used to modulate a carrier of frequency 1 megahertz and peak voltage of 20 volts. So, one is a carrier wave frequency given to you, one is a message signal frequency given to you. So, you need to determine the modulation index and the sidebands. So, modulation index, so please make sure here this peak voltage. So, peak voltage here corresponds to, as we already termed whenever we were talking about the concept of amplitude, in brackets always it was written as voltage or current. So, if the concept, if the word voltage is not written, please do not get scared. If the concept of voltage or current is also written, you can directly implement it as an amplitude. So, voltage or current can be used as an amplitude. Okay. So, very simple question. So, modulation index is nothing but AM by AC. I reverse the concept here. So, it is nothing but AM by AC, which is equal to 10, that is the message signal wave. Message signal has a frequency of 10 kilohertz and hence message signal is AM, which has a voltage of 10 volts, and we divide it by 20, which is equal to 0.5. Hence the modulation index 0.5. When we were talking about the concept of modulation index also, there was a line written which is that modulation index is generally kept always between less than or equal to 1. So, it is quite peculiar, it is quite easy to say that 0.5 is less than or equal to 1, hence the concept we are deriving here is right. So, modulation index is nothing but 0.5 here, and the next concept was determine the side bands produced. So, side bands is nothing but so we have the we have the angular frequency of omega c, we have the angular frequency of omega m. So, side bands are nothing but omega c plus omega m and omega c minus omega m. So, just a simple calculation. So, it is 1 megahertz, we need to convert it into kilohertz. So, just again I am iterating to you. So, 1 kilohertz is 10 to the power 3 hertz, then 1 megahertz is 10 to the power 6 hertz, and 1 gigahertz is 10 to the power 9 hertz. So, if we need to convert megahertz to kilohertz, so 1 megahertz is equal to 10 to the power 3 kilohertz. So, hence this will be equal to 1000 kilohertz. Now, as the equation as the units are now same, so it can be directly added up. So, it will be 1000 plus 10, that is omega c plus omega m, and another will be omega c minus omega m, that is 1000 minus 10. Hence, we got the side bands as 1010 kilohertz and next as 990 kilohertz. So, this was a simple problem which is now completed. Let us move on. So, now please look over this equation, please look over the square law device. This is a mathematical formulation I was talking to you about in the last lecture also, last part also. So, this is quite typical, but please make sure, please listen carefully, everything is quite easy if you pay attention. So, let us move on. So, first of all just see the figure here. So, the figure, first of all let me explain to you the complete figure so as to make it more clear. So, as you can see at this point there is a modulating signal which is being transferred. So, modulating signal is m of t, which is equal to a m sin omega m t. Next is carrier wave will be added up here, that is denoted by c of t, which is a c sin omega c t. These two being added up, then there is a modulated signal which we get. Then modulated signal, let us denote that modulated signal by x of t. That x of t is nothing but the addition of both of this, that is a c sin omega c t plus a m sin omega m t. So, this is the thing we got from this concept. Next is, let us denote that x of t is equal to here. So, this is m of t plus c of t. Now, there is something called a square law device. What the square law device does is, it makes that signal in the form of y of t. let me iterate it only as long as it is required for class 12th people. So, for now square law device, what it does is, if I input an x of t function there, then the y of t function which comes out, or the modulated signal or the signal processed out of it, has an equation which is b multiplied by x of t plus c multiplied by x square of t. So, now we got a y of t function. Please do not go into peculiarity of why we are doing square law device for now, why is there a need. If there will be a need, I will explain it to you, but for now just explain that the input is x of t and we get y of t, which is equal to b x of t plus c x square of t. After this, there is a band pass filter. What is the use of band pass filter, we will get to know in subsequent slides. And finally the wave which we get which we get as an output from a band pass filter is known as a AM wave. So, this is the procedure, or this is the way in which we get an amplitude wave, and finally the concept is being done, and then the transfer is being done of a low frequency to a high frequency. With a high frequency signal, the low frequency information can be transmitted from point A to point B. So, this figure has been clearly explained to you. Let us move on to every point written here. So, first point is, so amplitude modulation can be produced by a variety of methods. A conceptually simple method is shown in the block diagram in the figure. So, this was the block diagram being explained to you. So, now here the modulating signal AM sin omega mt, modulating signal is the wave or the signal which we want to modulate, as in which we want to add up with a with a carrier wave for its transmission or for its communication from point A to point B. So, here the modulating signal AM sin omega mt is added to the carrier signal AC sin omega ct to produce the signal x of t. This signal x of t is nothing but the addition of both. So, x of t is AM sin omega mt plus AC sin omega ct, is passed through a square law device. What does a square law device do? It is a non-linear device which produces an output. What is the type of output here? That is y of t is equal to b multiplied by x of t plus c multiplied by x square of t, where b and c are constants. Now, so now what does this equation becomes is, I will explain very clearly here. So, from the last slide we got x of t is equal to AM sin omega mt, AM sin omega mt plus AC sin omega ct. So, x of t is equal to AM sin omega mt plus AC sin omega ct. Now, we know that y of t is nothing but b multiplied by x of t plus c multiplied by x square of t. Let me write it clearly. So, this is the thing. Now, we just need to substitute the equation number 1, let me denote by equation number 1 into this next equation. So, what we will get is, let me write it here because it is a very long statement. So, it will be b multiplied by AM sin omega mt plus AC sin omega ct plus c multiplied by AM sin omega mt plus AC sin omega ct whole squared. Now, evaluating it more. So, if we open the bracket, we will get b AM sin omega mt plus b AC sin omega ct plus, now if we will open the squared bracket and add up with sign of c, we will get is c AM squared sin squared omega mt plus c AC squared sin squared omega ct plus 2 AM AC sin omega mt sin omega ct into c. So, that is 2 AM AC sin omega mt sin omega ct. So, this is the final equation which we got for y of t, which is again written here. So, this was the equation. So, you can again clarify also. So, it is B am sin omega mt plus BAC sin omega ct plus CAM square sin square omega mt plus there will be a C here, sorry. So, CAC square sin omega square with the omega ct plus 2 AMAC sin omega mt sin omega ct. So, this is the first line here. Now, for the second line, more mathematical formulation is required. So, for the second line there are some trigonometric identities to be used. So, the first trigonometric identity, let me write it by different color for more clarity. So, the first trigonometric identity is nothing but use of sin square a, which is equal to 1 minus cos 2a by 2. This is the first, and second we just need to use the same formula which we used a little back, that is sin a sin b is equal to half of cos a minus b minus cos of a plus b. So, let me write it there only for your quick reference. So, just to check again, I will go to the last slide again. So, sin a sin b is equal to half of cos a minus b minus of cos a plus b. So, sin a sin b is equal to half of cos a minus b minus cos a plus b. So, now using these two identities we will again, just formulate the equation which is written here. We will formulate this equation. So, this equation it will become, let me write it in the below. So, y of t is equal to b am sin omega mt plus b ac sin omega ct plus, now in the place of sin square we will use 1 minus cos 2a by 2. So, that will be equal to c am square into 1 minus cos of 2a by 2 plus c ac square into 1 minus, sorry, not cos 2a, this will be cos omega m, this will be 1 minus cos 2 omega c by 2. So, from till here it is completed, and then last line would be in the place of 2 sin omega mt sin omega ct we will write am ac, there will be a c here also, c am ac into, in brackets, cos of omega m minus omega c into t minus cos of omega m plus omega c into t. So, this is the formulation. Let me stop the formulation here only for this lecture. In the next lecture, just a single step has to be required for this to iterate. Let me stop it here only. So, this was the only typical formulation required. In the next lecture we will complete it. For now, thank you.